system is very near. So let's have this one. A Toyota Land Cruiser drives east from point A. This is point A. It drives towards the east at 30 kph. So the velocity here is 30 kph. So using the formula S equals velocity times time, so the velocity is 30 times time. So the distance traveled by our car starting from A due east, so this distance is 30, the velocity times the time. kph, so time must be in R. On the other hand, another car, a Ford Expedition at B, that is 30 kilometers away from A, drives towards A at south 30 degrees west. Meaning, from B to A is south 30 degrees west because our car at B drives directly towards A. So A and B are initially 30 kilometers away, and the velocity of the expedition starting at B is 60 kph. So at any time t, the distance traveled by our car B is S is VT, V is 60. So this must be 60 times t. Velocity times time, this is kph, so t must be time. Must be time in R. So if this is 630, this is 60t, this must be 30 minus 60 times time. So the question here is we are asked here to find how fast is the distance between the two cars, car starting at B and car starting at A. How fast is the distance between them changing after 30 minutes? Right? At any time t, the distance between them is this distance. This is S. If this is 30 from this right triangle, if this is 30, this must be 60 degrees. So if we're going to apply cosine law in this triangle, this one, the square of this, that is S squared, is equal to the square of the other two. This is 30t quantity squared plus the square of the other, which is 30 minus 60 times t squared minus twice their product, 2 times 30t times 30 minus 60t multiplied by the cosine of the angle opposite S, or in between 30t and this one, which is 60 degrees. Cosine 30 degrees is 0.5. 0.5 times 2 is 1. So I can just eliminate 2 times cosine 30. That is equivalent to 1, right? So therefore, simplifying this, we will have S squared is going to be, this is 900t squared plus 30 minus 60t squared is the square of the first, 900 minus twice their product, 30 times 60, that is 1800 times 2, twice the product, this is 3600 of t plus the square of the second, this is 3600t squared. While this one is 30t times 30, this is 900t, and this is negative, so this is minus. So 30t times minus 60t times minus, so this is plus. 30 times 60, that is 1800t squared. This is already plus because this is minus, minus, so that is plus. So simplifying further, we will have here S squared is going to be combine the t squared 900 plus 3600. This is 4500 plus 1800. So that is going to be 6300 t squared. Combine the t terms, no? So this is minus 3600 minus 900. This is minus 4500 of t. And the constant term is 900 plus 900. Now, when t is 0.5 hour or 30 minutes, when t is equal to 30 minutes, or this is 0.5 of an hour, you substitute it here, and then shift solve, you'll be able to get S is equal to 15 kilometers. Or simple common sense, 60 times 0.5 is 30. So, 30 is this one. After half hour, car starting at B is already at A. And 30 times 0.5, that is 15. So this would be the position of the Ford Expedition, while the position of Toyota Land Cruiser is 15. So they are 15 kilometers away after 0.5 hour. Right? Okay, so S is 15. You get it? But it's not S that is missing, but ds dt. How fast in kph is their distance changing? Okay? So we know here, from this equation, we take the derivative with respect to time. So I will continue here on the left side. Derivative of s squared is 2s to the 1. Derivative of s with respect to time, ds dt, is equal to derivative of this. Derivative of this is 6300 times 2. That is going to be 12600 times t. Derivative of time with respect to time, 1. Minus derivative of this is 4500. Derivative of 900 is 0. Now, when t is equal to 0.5 hour, our s is 15 kilometers. You substitute here, this is 2 times 15 ds dt is equal to 12,600 times 0.5 minus 4,500. One equation in terms of ds dt. You solve this equation and you will get your ds dt is going to be 60 kph. So this is the rate by which the distance between them is separating after 0.5 of an hour. You get it? Okay. What about this one? A ship having a displacement of 2,400 metric tons. Metric ton is 1,000 kilogram. Meaning the water displaced or replaced by the barge is equal to 2,400 metric ton. Wow. It's a weight, right? Rather than a volume. Meaning the weight of this volume of seawater is 24,000 metric tons. Meaning the weight of this barge is 24,000 metric tons. You follow? And our draft, the portion, the vertical height is called the draft, 10.4. The portion that is floating is called the flotation. So this is 10.4 meters. The question is, it enters a harbor of fresh water. Since seawater is heavier than fresh water, the specific gravity of seawater is 1.03. So if you replace that by fresh water, then you will need more volume in order to carry the 2,400 metric tons. So it means when you enter it or submerge it to fresh water, the depth of submergence must be more than that. So this is going to be the fresh water level. Okay? So let us say that the additional submergence is Y. According to the problem, this area, this one, the area of this section is 3,000 square meters. This one. So we are asked here the draft in fresh water. So that would be 10.4 plus Y. You get it? So how are we going to solve it? This is it. Let us say that this portion is V1, the volume submerged in salt water. And then let me call this additional weight or additional volume when it enters the harbor with fresh water. Let us say that this is V2. We say the initial condition when it is still submerged in salt water, that is W is equal to the weight of displaced salt water. That is the buoyant force, right? So the weight of barge, which is 24,000 metric tons, is equal to the buoyant force, which is 24,000, or this is density of salt water times the volume of salt water displaced, that is V1, right? But density of salt water is specific gravity 1.03 times density of water. So the density of water in metric tons is 1,000 kilograms or 1 metric ton per cubic meter. So therefore, this is going to be 2,400 equals 1.03 times 1. So this is density of salt water times V1. Your V1 therefore is equal to, if you compute this, you'll get 23,300.97 cubic meters. Okay. So this is our V1, the volume of displaced salt water. Now, this one is now in salt water, so the total displacement is V1 plus V2, right? So we say that our weight of barge, 2,400 or 24,000 metric tons, is equal to the buoyant force due to fresh water, which is what? It is equal to the density of fresh water multiplied by the volume. So which is V1 plus V2. Right? So this is going to be 24,000 metric tons. Gamma of water is 1 metric ton per cubic meter times V1, which is 23,300.97 plus V2. V2 is area times height. Area, I presume that this is constant area, this portion. So this is going to be 3,000 times Y. That is V2. So one equation in terms of Y will be able to get our Y, and Y is 0.233. So therefore, the new draft or submergence is 10.4 plus Y. 10.4 plus Y is 10.4 plus 0.233, this is 10.633 meters. This is the new volume submerged. You follow? Okay. Let us have the third problem in situation 1 of design. Now, a simply supported girder of a bridge that spans 25 meters, that this is 25, the standard track load consists of two moving loads that are 4.3 meters apart. The loads are 142.4 and 35.6. The total is 178. Find the maximum shear at the center of the girder. So we need here the influence line for shear at the center line. So how do we do that? So what we're going to do is we are going to take this as the ∈ point. And this is our beam. If we want the influence line for shear at the center line, we cut this. Once we cut the center, we connect them by the 1 unit helical spring. So it's just like this. You cut it here. This is the center line. Okay? So one segment is on the one end of the helical spring while the other is here. And when you release it, twang, the right will go up, the left will go down, right? Yung right, righteous, itataas. Yung kaliwete, unfaithful, ibababa, right? And this remains parallel, okay? So, these are ∈ point. This will move up, this will move down. This is a ∈ point, this is a ∈ point. It will be like this. Twang. So, something like this. This is your 1 unit spring. This and this are parallel. If they are parallel, meaning if I extend this, since this is 1, this is 1, right? And this is 25, this is 12.5. You follow? Okay. So by symmetry, this is at the middle of this. If this is 1, this is 0.5. This is also 0.5. The maximum ordinate is positive 0.5 and negative 0.5. This is the maximum shear at the center line if the moving load is 1 unit load. So however, our moving loads are this and this 4.3 meters apart. So what we are going to do for maximum shear at the center line is we put the bigger load 142.4 on top of where the ordinate is maximum. And take note that 4.3 meters away is the other load, 35.6 kilonewtons. This is 4.3 meters. This is 12.5 minus 4.3. This is going to be equal to 8.2 meters. 12.5 minus 4.3, 8.2 meters. So therefore, the ordinate here, this one, using y is mx, this is mx. My favorite analytic geometry formula. Okay? Y is mx. The slope is 1 over horizontal, vertical over horizontal, 1 over 25. And the x for this triangle is what? This one, which is 8.2. So this is going to be 0.328. Okay? So therefore, our maximum shear at the center line is going to be, if the load here is 1, it's 0.5. However, it's not 1, but 142.4. So you just multiply this by 142.4. plus by method of superposition. If the load here is 1, the additional shear at the center line is this one, 0.328. However, our load is not 1 but 35.6. So just multiply this by 35.6 kilonewtons. So you calculate this, and this is going to be equal to 82.88 kilonewtons. So this is going to be the maximum shear at the center line. You get it? You follow? So you just multiply the ordinate by the value of the concentrated load above that point. You get it? Okay. Ini-invite ko po kayo na mag-enroll sa paparating na November 7 to November 14 final coaching program po namin. Ano po ang highlight nitong final coaching program natin? Number 1, it will be a complete discussion of complete Civil Engineering Board Exam November 2019. Yan yung po yung pinaka-latest. Iba kapag ka nakita mo yung latest, yung talagang as in latest board exam, dahil yung probability na mauulit yung ilan o mga 20% ng mga problems na yan, mataas po. So saka based on that complete, bali po mga 200 problems na isosolve, makikita mo, magkaka-idea ka ano ba yung mga possible pang lumabas. Pangalawa po, dahil lalo na yung mga medyo nataranta, kinapos, meron po tayo ng pangalawang highlight nitong coaching program, yung survival techniques. Ano ang gagawin mo kapag hindi mo na alam kung anong gagawin? Di ba? Hirap, di ba? Pangatlo po, ang highlight po is tuturuan ko po kayo nung scientific guessing. So, paanong manghula nang yung hula mo mas malamang tama? Kasi kapag patsamba-tsamba ka lang na blind guess, walang art, walang science, yung panghuhula mo malamang mali. Di po ba? Pero ito po, ituturo ko yung science ng pag-guess ng tama. So enroll po kayo dito sa final coaching program natin ngayong November 7 to November 14 po. Ito po ay para sa preparation natin sa November 14 to 15 Civil Engineering Board Exam. So, kita-kita po tayo.